Well, with that last video, we had the camera following our character who moved around from the video before that, but we quickly noticed that the character could walk right past those walls. So we need to restrict how far our character can move. We don't want it to leave the room here where we're setting our scene up. So we need to set up those bounds. And so first thing is probably figure out where they're at. So what I like to do to check things like that is I'll just grab the player character here and drag him around and see where the position is. So maybe that's as far over as he can go. And we can see here, the furthest that goes will be an x of negative 17.53. So we don't want him passing that. So grab the notepad here and go negative 17.53 on the x. And then on the y, he can go as far up as about here. That looks good. So we can see the y is 9.92. So I'm just going to say 10. That'll probably still be pretty close. On my notes, I'll go ahead and copy 9.92. So you can go from those. So if you haven't seen it before, to define a rectangle, we only need 2 points. We have an xy coordinate up in this corner, and an xy coordinate down in this corner. And those 2 points tell us how wide something is and how tall it is. So if we keep moving our character, you can probably come over about that far, which is an x of 17.87. So we'll go over to 17.87. And it's handy to have some paper or someplace to jot down notes for reasons like this. And then as far as this way, looks like the character can go down about that far, which is a y of negative 12.18. Negative 12.18. So there's the coordinates we need to restrict our character to. Negative 17.53 to positive 17.87 on the x-axis, and negative 12.18 to positive 9.92 on the y-axis, which is going to make a nice little rectangle. So we can set that up as a variable. Unity has many types of things we can work with, many types of variables we can create. One of those being a rectangle. So if we create a variable called boundary and set the type of it to a rectangle, which isn't immediately on this list, we could dig through and find it, or we could just search for rect. That is a common type of thing. Whoop. I didn't realize I clicked it, but it apparently found it and inserted it. There was only one result to that search. And we can see we need an x and a y coordinate to start, so that's like one of our corners. Then how wide is it and how high is it? So I'm going to bring in some of these numbers. So an x, the lowest we can go is 17.53, and the y, I'll do the 9.92. So that's the upper left corner. Then there's a slight issue, because I used exact values, but this doesn't seem to want exact values. It doesn't want an x2 and a y2. It wants to know how wide is it. So from negative 17.53 to positive 17, that sounds like about 35. It's about 35 units wide, and then height goes from positive 9.92 down to negative 12.18. So it'll be about 20 tall. So we can just check that and see if those numbers work. And really, that's just a starting point. We might need to come back and adjust them. So you want to pick a starting point, get a reasonable starting point, run it, see what happens, and then make any adjustments as necessary. So now we can throw that in a script. And, well, we already have a player control script. So we can just use this script to put it in. And we will need a reference to that rectangle variable we just created. So I'm going to drag that over, then double click this to make it full size. So we have room to see what's going on. So this is going to be the next piece in our flow. So on the update event, every frame of the game, we're going to move our character depending on which controls are pressed, or if the controls are pressed. Then afterwards, we want to make sure we're still in the scene. So again, I'm going to look for a transform. And my thought on this is if we pass that boundary, we can just pop the character back inside of it. So similar thing to what we used on the camera. So we'll move our character with a transform translate, but we're going to restrict it to this rectangle. And if it passes it, we'll just pop it back in there. So now we need those. So we get this rectangle value, and but we need some other things. So we'll get the rectangle value, and then we'll get the position of the character. So add unit. If I put in get position, hopefully it'll find it here. So a transform.get position. If I zoom in on that, that's referring to itself. So we have the character's position and the boundary at every time. So we need to find just a couple things. We don't need the entire position. We just need a couple values off of it. We want to know the X and Y. So last time we saw, in the previous video, we saw pulling those out directly. But maybe you don't know for sure what it is. So another option we have, if we drag this out, if we type expose, well, actually, if I don't type in there, the first thing it tried to predict is a vector 3, because our position is a vector. It's a number, special type of number that includes the number, the size of it, as well as the direction in which it pushes, in which it points. So we choose that first prediction, and then the first prediction again is expose. And we'll often find ourselves using these. Expose tells us everything there is to know about this vector 3. So here's all the stuff about vector 3's, and in there is an X and a Y component. And we can do the same thing with this variable, our boundary, which is a rectangle. Drag it out, and well, the computer's not quite sure what type of variable it is right now, but we can type in expose rect. And expose just means bring out all the information about it. That way we can see what we have to work with. So here's all the stuff about the vector 3 saying where our character's at. Here's all the stuff about the rectangle saying what that is. In particular, we have an X and Y here. And on that rectangle, we have an X minimum and an X maximum, and same thing for the Y's. So we just want to restrict our character XY to be within that min and max. We do that with a function called clamp. So we'll add another unit and search for clamp. And this first one, so mathf, that's math for floating point numbers, and we're going to clamp something between a min and max value. So that's the one we want. So we'll select that. And what we want to clamp is we want to clamp our X value between, I need to get where I can see both of them, between our X minimum and our X max. And then we can do the same thing for the Y. So I already searched for that, so I'm just going to push Control C to copy it, then Control V is in vacation to paste it. And we're going to clamp the Y value somewhere between our Y minimum and our Y maximum. So that will restrict those numbers. And once we have that, we'll create a new vector 2. Add unit, create vector 2 instead of a vector 3 because we are only adjusting x and y coordinates. So we're going to create a new vector 2 from x and y coordinates, and it will be those restricted values we just passed in. And then that is what we want to set our position to. So each frame of the game, our flow goes over to the translate. So we'll try to move the character. But then after it moves, we'll have the computer check very, very quickly if we've passed our bounds. And if we've passed our bounds, it will bounce it back into it. So that's how we set up, one way to set up restrictions here. So let's run that and see if our character is now restricted to those bounds. Bring him over here inside the camera, around the middle again, and hit run. So as soon as it started running, it bounced the character up to the top. So I think I might have to adjust those variables for which way, how tall that is, because if I push up and down, well, he still moves up. So it looks like that height probably should have been negative, because as low as we can go looks like the upper wall. But then left and right, if I go to the left, our character can move all the way over to negative 17.53. If we move to the right, the character can move all the way to 17.47. So 35 units wide, which is good. But set up that rectangle to start at 9.92 and then set a height, which apparently should have been negative because it allows us to go up but not down, which is an easy adjustment. So that's how that often happens. Stop that run, come over to the scene variable and adjust that. Instead of 20, let's try negative 20 for a height. It has a height of negative 20 units, so then it goes down instead of up. We'll run that again and see if that works. Well, the character didn't bounce right to the top, but that's definitely not what's supposed to happen, right? So that's probably the wrong value. Let's stop that and try something different. So stop that run. And perhaps the problem was that instead of starting at the top and going down, we should have started at the bottom and gone up, which are here in the notes. So instead of starting at 9.92 and trying to go down, let's start down at negative 12.18 and go up, 21 units or so? So change our y for our rectangle variable to negative 12.18 and then have it go up 20 units from there. Allow it to go up that far. Let's run that and see if that works. Well, now the characters didn't bounce to the edge of the screen, so that's something. So if I push up, it goes up and up and up and stops right before that wall. You can probably come a couple more units beyond that, a little bit of refinement. If we go down, stops right above the wall. So I'll make that a little bit higher. But it often happens in programming that we do stuff like that. We pick a starting point and then just make adjustments until we get to where we want. So it looks like I need to come a little bit higher, and there's no need to watch that in the video. So I'll go ahead and move on to the next video and adjust that upper bound to 2 or 3 units higher until I find where he stops right before the wall. Stops right up here instead of down here. So I just adjusted that height value to 22, and it looks like the character stops at a much better spot now. So that's how we restrict the character to the room. Next thing, we need some other characters in the room. We need some NPCs, some side characters, so that something happens. So let's do those in the next tutorial.